37, what did they tell us? We're solving the equation, the cotangent of x equals negative 0.6. And they're telling us that they want values of x between 3 pi over 2 and 2 pi. So even though we're going to solve this with a calculator, we do need to use our, we're going to need to make a reference triangle. So let's go ahead and set that up. And our reference triangle needs to be in the right quadrant, and they gave us some pretty solid information about what quadrant we're going to be in. 3 pi over 2 is 207, no wait, yeah, 3 pi over 2 is 270 degrees, 2 pi is 360 degrees. We're talking about quadrant 4. So let me set up, hi, my reference triangle. Thank you. Cupcake Wars. All right. So this is the angle. This is my reference angle. But this is not x. The reference angle is an acute angle that's inside of our reference triangle. But when we're talking about the actual angle for this position, we always have to start from the standard 0 degree position, rotate all the way around to here. Bless you. So in a moment, I'm going to figure out what this angle is right here. And when I do, to answer my final, to get my final answer, I'm going to say, well, if they wanted degrees, I would say 360 minus whatever that angle is. But this is radians. We're not going to use 360. What are we going to use? So my final answer is going to be 2 pi minus whatever that angle is in that reference triangle. Okay. You guys with me on why I've got to do 2 pi minus something to get the answer here? Yeah, the reference angle is not the same as the angle. The reference angle is a convenient angle that helps us think about every angle on the unit circle as an acute angle, but it's not the actual angle. So, all right, so we just need to figure out what goes in this box. So I'm going to give this a name right here. We're already using x. Maybe I'll call it theta. So this is x. This is theta. And I'm going to, well, I'm going to put my ratio onto my triangle. Cotangent is 0.6 over 1. Actually, why don't we just solve the equation? Nah, I'm going to put it on here. 0.6 over 1. Cotangent is adjacent over opposite, right? 0.6 and 1. And I'm going to use this to write an equation. Cotangent theta equals 0.6 over 1. Now, something seems fishy here. Okay. We could. Yeah, absolutely. So for example, if 0.6 is 3 over 5, so instead of 0.6 over 1, I could have done a 3 and a 5 here. It's still the same thing. Yeah. Okay, so now, is this bothering anybody that, like, we were asked to solve the cotangent of x equals negative 0.6, but we're actually going to solve cotangent of theta equals positive 0.6? Is that bugging anybody? It was bugging me for a second. You guys are just accepting that on faith? I was looking at it and I was like, no, I think this is going to be okay, because remember, our final answer, we're going to do 2 pi minus something, right? So let's go ahead and do this. Now, back in geometry, you learned how to solve equations like this. How do we get rid of a cotangent? We take the inverse cotangent. Ew, but we don't have an inverse cotangent button on our calculator. Backtrack. Let's change this equation. If I did a reciprocal here, if I wanted to change this into a tangent, I'd be doing a reciprocal. Agreed? So tangent theta equals, but I got a reciprocal over here also, 1 over 0.6. Okay, now let's get rid of our tangent. We'll do an inverse tangent of 1 over 0.6. I'm grabbing my calculator, making sure I'm in radian mode because they asked us for angles in radians. Yes, I'm in radian mode. And I'm going to do the inverse tangent of 1 over 0.6. All right, and that's my theta. It's about 1.030. And then I'm going to subtract that from 2 pi. So I'm going to do 2 pi minus, do you know this little trick? If you do second negative key, it'll give you 2 pi minus whatever your last answer was, and then you don't have to worry about typing that whole thing out again. Were you guys aware of that little trick? And ANS was from second negative key. And that's it. I think that my answer is about 5.25 radians. But I'm going to check it. How could I check it? What if we plugged it back into our original equation and see if it worked? Yep. I'm going to stow this as x. And then I'm going to do the cotangent of x. Now, I don't have a cotangent button, but I can type 1 divided by tangent x. And there we go, negative 0.6. I'm feeling pretty good about that. Yes?
So when we did the cotangent of theta equals the positive 0.6 over 1, is it just always changing sign for that?
Well, we're dealing with just this right triangle here. And this right triangle has, we don't think about negative side lengths. Okay, so these are always just positives.
Okay.
Who's that for?
This is for the blood drive. Just for students who donate blood.
Oh, so if anybody needs food. Okay, there's snacks in the back if anybody needs it. Thank you so much. All right. Anybody being bothered by the fact that this 5.25 doesn't have a pi after it? And it's radians? You're not bothered? Oh, good, good. Some people would be bothered. It is possible to talk about 1 radian. Radians don't have to have pi's in them. Oftentimes they do. They don't have to. Yeah. All right, what else can we talk about, folks? 39 is going to be the same idea, but we'll get it started. I'm going to let you finish it, though. I'm not going to go through the whole thing. Let's see. It could be on an axis. Cosecant x equals 2, and 0 is less than or equal to x is less than or equal to 2 pi. I'm actually going to solve a different equation. Cosecant I'm not super familiar with. I'm going to flip this, do a reciprocal on both sides, and instead solve sine of x equals 1/2. So we're going to solve this equation instead. Are you guys comfortable with the idea that these two equations are equivalent? They mean the same thing. So if I solve this, it'll be the same solution as if I solve this. 0 to 2 pi. This is an interesting one. So where's my reference triangle going to be? Well, so where is sine positive? Sine is positive here. So we will have one reference triangle here. And we are going to have a reference triangle here. And we don't have enough information to narrow it down between the two, so we're going to end up with 2 answers for this. We're going to end up with 2 answers. One of my answers is going to be the same as the reference angle, and the other one I'm going to have to do 180 minus whatever that reference angle is to find it. There's some stacks in the back if you need. So those are going to be my two values for x. So let's solve this. I think we can just go ahead and do our inverse sine on both sides. Right? Well, let's do this. So we'll make that theta. Sine x is 1/2. That's opposite over hypotenuse. Actually, we don't even need it, do we? 1 and 2, what is it? This is a 30, 69. Is this the 30 or the 60? That's the 30. So pi over 6. That's one of my values. So x is pi over 6, or what would this other one be? This is also going to be, if this is my reference angle, it's still 1 over 2. So it's still a 30, 60, 90 triangle. So my reference angle is still 30. So then we'd be looking at 150. What's 150 in radians? 5 pi over 6. So there would be my two solutions. I'm just going to check and make sure those work. It said solve use a calculator, but we didn't even need a calculator for that one. So sine of pi over 6 is, I want to do h, 0.5. And sine of 5 pi over 6 is also 0.5. Hooray! Many of you are going to memorize those two numbers. For our next memorization quiz, which is not going to happen until a couple weeks into the new unit. So it won't be next week or the week after that. I got to give you kind of there's some tricks to memorizing the next one. Makes it a lot easier. Okay, we got time for one more. 41, D and E. Explain why the period of tangent function is pi and why the cotangent function is pi. We can do that, sure. And then we'll come back to you. Yes, you don't have to ask it. The pass is there, just you. 41, D. We don't need the picture or anything for this. They want to know why is the period equal to pi for y equals tan x. Are you comfortable with, for sine x and cosine x, that the period is 2 pi? Are we feeling okay about that? Yeah, how do we put it into words? So I would probably base it off of this. I'm going to make a sketch of sine and cosine. Here's 2 pi. Sine would look like this, right? And cosine looks like this. So why is it 1 pi instead of 2 pi? In other words, why does it repeat itself after this? So I'm looking at it kind of visually. And what I see is that this little piece right here, like look at these two curves between here and here. I'd say that that pattern repeats itself, but it's just been flipped upside down after that pi. Do you guys see that as well? But if they've both been flipped upside down and we're dividing it, isn't that flip, that negative, going to kind of cancel each other out? That's kind of how I'm seeing it visually. I don't know. So look at this pattern. You see this kind of, see how this and this sort of create, I don't know, it's this, look at this little shape here. What do you say? This looks like a part of a leaf or something like that, right? And then this little piece coming off of it. I'm seeing that same kind of leaf right here. It looks like the same pattern as this. It's just everything's been flipped over upside down. To me, that visually looks the same as this, but flipped upside down. Agreed? So if you can agree with me on that, then I would say that when I divide these two things by each other, like to make this couldn't I just take both of these and multiply them by -1 to flip them? Right? Well, we're going to divide them both. What happens when I multiply the top and the bottom of a fraction by -1? Does that change it? No. So this is going to be exactly the same as this when we graph the tangent. That's not a great explanation, though. Who's got a better one? What'd you write? 2 pi over 2 pi is 1, yes. Sine over cosine, yes. I don't think we can translate, if you're thinking about translating sine over cosine, I think I see you kind of thinking, oh, we'll call that 2 pi over 2 pi. Yeah. Nah, that's not going to work for us because we can't, I don't think we can just like replace something with its period. Yeah, I like what you're thinking there. And there may be a way to kind of work that in. What's another way to look at it? We haven't talked too much about this, but let me show you something that'll come up later. I don't want to get into, there are probably a dozen different great answers for this, and I don't want to get into too deep into it, but look at this for me if you would. This point is on my unit circle, right? And we know that the sine is the y coordinate, right? And the cosine is the x coordinate. Let's call it theta, not x. We're comfortable with that? So the sine is the y coordinate. This is the sine. And the cosine is the x coordinate. That's the cosine. Then I want you to think back to algebra 1. For this purple line right here, what is the tangent? If it's sine over cosine. What did we do in algebra 1 where we make a fraction out of the rise and the run along a line? Tangent is the slope. Tangent is the slope of that line. That will make that big, that's going to be a huge connection for us next chapter. So sine is the x coordinate, sine is the y coordinate, cosine is the x coordinate, and tangent is the slope of that hypotenuse. Okay? Always. Okay? Now, so if we think about the slopes of these things, imagine I've got a little line right here, and I start rotating it around. We got positive slopes, right? All the positive slopes up to infinity, and then we start getting the negative versions of all those things, right? And I get around to here. Now, what's going to happen when I keep going? I'd say I'm going to start repeating some of the slopes that I already did, right? The slope of this angle is the same as the slope of this angle. We already did that once, right? So we're going to see the same slopes repeated twice as we go around the circle, which is pi. Yeah. So there's another way to think about why it's pi instead of 2 pi. All right, you had a question, and then we got to move on. Gets to the same position. Yeah, cool. All right, let's do this. What I'm asking you to do here is identify. We're gonna try and run through this first part a little bit quicker than I did first period today.